Okay, now we will do some examples. So in part 4 we will do the following examples. The first question or example says find the determinant of the following matrix. So we will do the example for a 2 by 2 matrix and some 3 by 3 matrices to prove some of the lemmas we have found earlier. So the matrix T1, 3, 3, 2. Okay, so we have seen in one of the lemmas that to find the matrix, the determinant of a matrix, we have to multiply down the diagonal in the echelon form. So what we have to do, the first step, is to perform Gauss's method, okay? Gauss's method to get the echelon form of the matrix T. So we have a T, which is 1, 3, 3, 2. So what we have to do now is 3 times minus 3 times row 1 minus 3 times row 1 plus row 2 will give us 1, 3, 0, minus 3 minus 9 plus 2 is minus 7. So as we have seen in the properties of determinant, if we get a matrix by doing row combinations, we do not change the determinant function. Okay, so here in the second matrix here, we have changed row 2 by doing the combination of row 1 and row 2. Okay, so we do not change the determinant. So the determinant of this matrix, the first matrix, is the same as the determinant of the second matrix. So the determinant of T, which is equal to the determinant of 1, 3, 3, 2, is the same as the determinant, as we have seen in the properties. Row combinations do not change the matrix function. Is the same as, is do not change the determinant function. So we have, it's the same as 1, the determinant of 1, 3, 0, minus 7. And this second matrix is in echelon form, so we can multiply down the diagonal. So the determinant of T is equal to 1 multiplied by minus 7, which is equal to minus 7. Okay, so this is our first question for today. Now we will do another question. So we have find the determinant of the matrix T, which is a 3 by 3 matrix. 1, 1, 1, minus 1, 1, minus 1, 1, 3, 2. So step 1 is Gauss's method. Okay. So we have 1, 1, 1, minus 1, 1, minus 1, 1, 3, 2. So we will perform the Gauss's method first. We have row 1 plus row 2. Okay, this arrow is too long. Will give us 1, 1, 1, 0, 2, 0. And here we have minus row 1 plus row 3. We have 0, 2, 1. Okay. Then we need to do minus row 2 plus row 3. 1, 1, 1, 0, 2, 0, 0, 0, 1. So the determinant, as you have seen in the properties of the determinant, doing row combinations do not change the determinant function. So the determinant of the first matrix is the same as the determinant of the second matrix is the same as the determinant of the second matrix. Okay, so the determinant of T is going to be the determinant of this matrix. 1, 1, 1, 0, 2, 0, 0, 0, 1. So what we have to do is to multiply down the diagonal. So we have 1 multiplied by 2 multiplied by 1, which is equal to 2. So the determinant of T is equal to 2. As you have seen here, and also in the properties of the determinant. So if you you change a row by row combinations, you do not change the determinant. However, if you multiply a row by k, then you have to multiply the determinant function by k. Or if you swap rows, then you have to multiply the determinant by -1. Okay, but if you just change one row by row combinations, then you don't change the determinant. The third question we will do today is going to be to prove one of the lemmas we have talked about earlier. So here we have a find the determinant of the matrix T okay, which is as follow: 1, 1, 1, minus 1, 1, minus 1, minus 1, 1, minus 1. So earlier, okay, in this section, the second section of this chapter, we have seen the following lemma. Okay, so if you see these two rows are the same, we have seen in the lemma that a matrix with two identical rows has determinant of 0. So let's prove it with an example. Okay, so I want to give the formal proof, but just do an example to prove it. Okay. If you need the formal proof, don't hesitate to let me know. I can also give you the formal proof. So what we have to do, step 1, Gauss's method. We have our matrix 1, 1, 1, minus 1, 1, minus 1, minus 1, 1, minus 1. So we have row 1 plus row 2 will give us the following matrix. 0, 2, 0. We have also row 1 plus row 3. We have 0, 2, 0. Okay. Now we have minus row 2 plus row 3. And if you so 0, 2, 0, we have 0, 0, 0. Okay, so now the second step is to multiply down the diagonal. Okay, so step 2, multiply down the diagonal. Okay, so the determinant of t is going to be equal to 1 multiplied by 2 multiplied by 0, which is equal to 0. Okay, as the lemma says. And okay, our last example for today will also to prove one of the lemmas. So find the determinant of the matrix T, which is 1 minus 2, 3, minus 2, 2, minus 1, 2, minus 6, 11. And you see closely, you will notice that the third row is a linear combination of the first two. So this third row is 4 times row 1 plus row 2. Okay, so earlier today we have seen in the lemma that a matrix with a 0 row has a determinant of 0. Okay, and as the third row is a linear combination of the first two, as you know from the first chapter when we introduced Gauss's method. If a row is the linear combination of other rows, then after performing Gauss's method, we will have this third row is going to be to become 0. Okay, so Gauss's method eliminate any linear combinations among rows. So let's see. Step 1, Gauss's method. So we have 1 minus 2, 3, minus 2, 2, minus 1, 2, minus 6, 11. So we have 2 times row 1 plus row 2, minus 2, 3. So here we will have 0, minus 2, here we'll have 5, and minus 2 row 1 plus row 3 will give us here 0, minus 4, here minus 4 plus minus 4, no, this is going to be 4 minus 6 is going to be minus 2, and here minus 6 plus 11 is going to be 5. Okay, so the next step is minus row 2 plus row 3. We have 1 minus 2, 3, 0, minus 2, 5, 0, 0, and 0. So as I said earlier, and as you have seen several times, okay, since row 3 is a linear combination of the first two rows, then after Gauss's method, row 3 is going to be reduced to 0. Row 3 will become 0 row. So now we have step 2 is to multiply down the diagonal. So here is our diagonal. We have the determinant of t is going to be 1 multiplied by minus 2 multiplied by 0, which is going to be 0. Okay, so this proves the lemma. So that will be all for today. This fourth part of the second section. In the next video, we will start the third part of this chapter. Thank you.